This is a video on ionic bonding. This is part 3, Criss-Cross and Reduce Model. It's for all ionic compounds, although in this video we are going to confine our discussion to the representative elements, groups 1 and 2, as well as groups 13 through 18 on the periodic table. In this model, we keep track of the charges that are created as ions form, rather than keeping track of the electrons as we do using the electron dot model. Remember that when compounds form, they're always neutral. That means the total positive charge equals the total negative charge for the ions that are in the compound. And really what that means is that the number of electrons lost in creating the positive charge equals the number of electrons gained as we create the negative charged ion. So if the charge is balanced, all the electrons are accounted for, and we are in keeping with the law of conservation of mass. It's easier to use the Criss-Cross and Reduce model than it is the electron dot model for ionic bonding. The electron dot model is really going to be something that's most useful when we study covalent bonding in a later chapter. The Criss-Cross and Reduce method has 2 steps. In the first step, we write the positive and the negative ions down. We always write the positive ion first and then the negative ion second. What we're going to do is crisscross the numbers of the positive and negative ion charges down to the bottom, although we just drop the positive and negative signs at this point. And then we reduce the ratio of the elements if possible. The second step in this process is to write the formula of the ionic compound. That is the lowest whole number ratio formula, or the empirical formula. The positive and negative signs are no longer written because the compound is always going to be neutral, and that means they're always going to balance out and give us 0 charge overall. Now, before we continue on and take a look at a few examples, just a quick review here. The charges of the ions formed by representative elements can be predicted based on which group they are in on the periodic table. All the elements in this first group have a 1 plus charge, in the second group 2 plus, and then moving through the rest of the representative elements, 3 plus, 4 plus for elements in this column if they come first in the compound, 4 minus if they come second, 3 minus, 2 minus, 1 minus. No charge for the noble gases. And remember that we always represent compounds with the positive ion first, negative ion second. So for now, let's just consider ionic bonding with only the representative elements. And then also a quick math review on ratios and how to reduce ratios. So for example, if you have a ratio of 4 to 4, we can divide 4 by 4 and get 1, and we can do that again. 4 divided by 4 is 1, and we can express that 4 to 4 ratio as a 1 to 1 ratio. That's reducing the ratio. When you can divide all the numbers in the ratio by the same whole number, you can reduce the ratio. If we have a little bit more of a complex ratio, like 18 to 6, 18 divided by 6 is 3, 6 divided by 6 is 1. Notice we divide both of these numbers by 6, and we end up with a reduced ratio of 3 to 1. So rather than expressing it as 18 to 6, we could express it as 3 to 1. Now you can do that incrementally as well. You don't have to divide by 6 there. For example, you could take 18 divided by 3 and get 6, take 6 divided by 3 and get 2, and initially take 18 to 6 and reduce down to 6 to 2. But we can reduce further. 6 divided by 2 is 3, 2 divided by 2 is 1. So 6 to 2, again, divide both those values by 2, becomes 3 to 1. So we keep reducing to get the lowest whole number ratio. Just a quick math review on reducing. All right, so once again, let's take a look at the 2 steps of the Criss-Cross and Reduce method. The first step is to write the positive ion first, the negative ion second, then crisscross the number of the positive and negative charges to the bottom, and reduce the ratio. All compounds are neutral, so the positive and negative signs are no longer written. Let's take an example. Magnesium bonding to oxygen to form magnesium oxide. So here we see magnesium, and it's going to have a 2 plus charge, and we can go back to our periodic table and take a look at magnesium in the 2 plus column, and oxygen is in the 2 minus column on the periodic table. So when we take 2 plus and 2 minus, this 2 crisscrosses down here, and this 2 crisscrosses down here. and we end up with Mg2O2. Now that 2 to 2 ratio can be reduced. 2 divided by 2 is 1, 2 divided by 2 is 1. So this reduces down to Mg1O1, or we could just write that as MgO as the formula for our compound. So once again, this is a two-step process. The first step is to write down the ions, and the second step is to show the formula that you get when you crisscross and reduce the numbers. Again, we drop the plus sign and the minus sign because overall the compound is neutral. Now you don't have to go through and show all this work all the time, but as a minimum amount of work, what you do have to do is write the ions and write the formula after you crisscross and reduce. Let's take a look at a few more examples. Here we have magnesium bonded to sulfide. So our first step is to write Mg2 plus and S2 minus. Once again, looking at the periodic table, we can see Mg is in the 2 plus column, S is in the 2 minus column. When we crisscross those numbers, we get Mg2, this 2 drops down here, S2, this 2 drops down here. So we crisscross the 2's down to the bottom. Now if we can reduce these, we should, and we certainly can reduce 2 and 2. They both divide by 2, so we end up with MgS. So once again, the work that you would be required to show for that is write the ions and write the formula for the compound that you get after you crisscross and reduce. Remember, we drop the plus sign and the minus sign because compounds are always neutral. Here's another example, aluminum oxide. This is where aluminum is bonding to oxygen. So if we take a look at where aluminum is on the periodic table, Al is right here, it's in the 3 plus column, and O, oxide, is in the 2 minus column. So we'll get Al3 plus and O2 minus. This 3 is going to drop down here, and this 2 is going to drop down here, and we're going to get Al2O3. Now in this case, 2 and 3 can't be reduced. So we're done. That's the end of it. Once again, write the ions that we get, Al3 plus, O2 minus, and then write the formula for the compound, Al2O3. Now, if you can do that work in your head, after, in other words, the moving of the numbers and the reducing in your head, that's great. But at the very minimum, I do insist that you write down the ion charges, the formulas of the ions, including the letters and the numbers that represent the charges, so that you can do a visual inspection that these ions would give you that formula. Okay, our last example, sodium sulfide. Sodium is Na, in Latin it's natrium, so Na1 plus, and then sulfide is S2 minus. So Na1 plus, S2 minus. Go ahead and crisscross those. This 1 goes here and the 2 goes there, and we end up with Na2S1. Now we don't write that 1 in formula, so we just write it as Na2S. If you see a formula and there's not a number written down here on the bottom, and the numbers on the bottom are called subscripts, then we assume that the subscript is an unwritten 1. So we would just write that as Na2S. Now, if you understand what we were doing here today, then you should be able to write the crisscross and reduce method, both parts, step part 1 and part 2, where we write the ions, and then part 2 we write the formula for the compound for these for these compounds. Sodium iodide, where sodium bonds to iodine. Magnesium chloride, magnesium bonding to chlorine. Aluminum phosphide, aluminum bonding to phosphorus, P is phosphorus. Boron oxide, where boron bonds to oxygen. And magnesium sulfide, where magnesium bonds to sulfur. Good luck.